Okay, guys, we're almost to the command line. So just, settle in and just, take a breath and just relax. We're almost there. Now, um, any way you've done this course so far, whether you watched every video in order or if you skipped around, it doesn't matter. Okay, the concept of you constantly doing this on a regular basis, okay, pat yourself on the back. All right, there's no, you have to understand 70 hours it takes me to go through all the CCNA topics if I was going to do a CCNA course. Okay, since I'm doing a different approach on this, because I really cannot stand even today how the CCNA has been restructured. Okay, I'm a strong believer if it's not broke, don't fix it. Okay, and the concept of them changing it the way they do, not a fan. Okay, not a fan at all. So, and and I'm not even gonna lie. It's not like I really fully understand it either. Okay, all right. It's one of those things where I'm just not interested in. All right, and since I already have my CCNA, I don't have to be interested in it. So nonetheless, so the switch, okay. Back in the day, which we're not gonna go through this whole history, we used hubs. Okay, looks just like a switch. Okay, however, we had two types of hubs. One that was passive hub. Okay, all right, and that means nothing was hooked up to it. It was just a box. Okay, inside the box, it was wired in order for that data to be shared across all other ports. Meaning, if you were plugged into port one, data that came into port one was shared throughout all the other ports of that hub. Okay? Great. All right? But everybody would always get all the data that was coming in on port one and all the other ports. Everyone was sharing data with everyone else. And, okay, that means you're eating up bandwidth, okay, or that you don't need, all right, because when the PC gets data that is not for it, okay, or himself or herself, whatever, it drops it. Okay, so imagine half your bandwidth being taken up on the wire for data that is just going to drop. Okay, all right. So, um, a active switch, a hub, was nothing more where it would actually take the data inside, make a copy of it, okay, kill the original data, and resend it. Okay, all right. Now, why would it do that? Well, when it's resending it as a new piece of data, okay, it is re-energized. Okay, so if Ethernet has the ability of going 300 feet, okay, or 100 meters, all right, without it being corrupted, because after that 300 feet, it's going to start losing its power. Okay, electricity does not last forever. Sorry. Now, hold on, I'm looking for something here. All right, we gotta move this monitor over a little bit because I'm messing up here. So now, but if we put an active hub at that 300 feet, okay, all right, I can actually, because of the way active hub works, by regenerating the packet, okay, for every packet that comes in, I get to go another 300 feet. Well, that's great. That means I can actually have a cable run that is 600 feet in length, as long as in between that 300 feet, I have some type of device that is going to re-energize that actual signal. Okay, so now that could be a repeater, an active hub, or a switch. Okay, so you find yourself having a 600-foot run. Okay, in between there, just put a switch in there, or an active hub, or a repeater. It doesn't really matter. Okay, as long as you're re-energizing that information. Okay, So, but those are hubs, okay? Now, interesting thing is, which we're going to discuss later on, but not in this video. Um, Hubs had a very serious issue with having a collision domain that was affecting everybody on that hub. Okay, so with a switch, we don't have that problem because each individual port it's its own collision domain, which is great. Don't worry about collisions. We'll talk about it later on. All right. So now, what we're going to do is we're going to go into our trusty switch. Okay, and I'm going to show you something. All right, and trust me, we're going to go through the command line. Trust me. All right, but for right now, what I want you to see is that a switch is a intelligent device. Okay, that, and I want to amplify. God, I have a loss for words today. I want to make a point. Yeah, I had to completely change that word that I was going to use. I have to make a point here that what you are doing here, besides learning an operating system, is you're learning how to operate, control, maintain, configure, create a environment from a managed device. You have to manage it. Okay? This device, router or switch, does not do anything unless you tell it to do it, unless you configure it. Okay? All right? Those stupid those stupid ass routers that you get from Verizon and Comcast, okay, or your ISP to get internet, yo, they are junk. Okay? They're junk. The ones that you buy, those LinkSense routers that you buy from Best Buy, dude, they're junk. Okay? And I don't care if you take that device and install that Linux router stuff on there. I can't remember what that is. Okay, you gotta understand these are not real managed devices, but they can be, okay, going down deep into that GUI. Okay, they use GUIs. Okay, I'm not saying that you can't get a LinkSense and put a Linux. I can't remember the operating system. To have a better operating system controlling that hardware. All right. Hell, you can even take a Linux operating system. Okay. All right. Take a PC, install Linux on it, and install a router daemon on there or whatever. If I don't know if it's a daemon or if it's actually software. All right, and turn your Linux device or your Linux PC or Linux server, or whatever you want to call it, into a router, a functional router. Okay, and yes, that will be what I would consider a management aspect because there's nothing configured on it. All right, okay. The Linksys devices that you get from there, you have things that are already installed where there is no management needed. You plug it in and it works. It works because it has been configured already. All right, your routers and your switches that we are working with Cisco don't do that. Okay, now the power of the switch. Okay, all right, and we're gonna go in here and we're gonna take a look at this with this command here. All right, now you saw how all I typed in was show Mac ADD. Okay, now if I do that again, okay, and I put a question mark. Yes, we're starting to learn things about the iOS. All right, if I put a question mark after that, okay, what it is doing is it's going to show you, which all you can see is the word show, everything that comes after that SHOW. So if I do SHO, still the same, SH, still the same, okay? See? S, anything that comes after S I have several commands: setup, show, sysstats, SSH, send. Okay, and it even shows you a star that S equals show. That means I don't even have to type in show. I can say show Mac. Okay, see that? Okay, pretty cool, right? This is the power of this operating system. And don't get me wrong, Linux is awesome too. Okay, but we're not talking about Linux. So that is what that means. If this was never taught to you, you would not know. You first of all, you wouldn't know this existed. Okay, and you'd be sitting there scratching your head like, what the hell is the name of that damn command? Now, if that is character and spelling of the commands, okay, all right, that question mark is there to help you. Context help, all right, is there to help you. All right, we're not going to remember all these commands that we're going to learn. Okay, all right, so we're going to say S. Oops. Okay, now how do I do that? Notice when I say S and I hit the tab key, it gives me that little, it's not going to work. Okay, that's because there's too many choices, and we know what those choices are by doing the question mark right after the character S. Now, how many SHs do you see there? Only one. So if I do SH and question mark, there it shows you the command because there's no other choices to actually choose from. Okay? I could do a question mark with no characters. No, look what that shows. That shows you everything. Okay? Every command that's possible to start off with. And there's my show command. Alright? And then a little description. Show running system information. Okay? Alright? Yeah, a lot of times it's vague. But, it's obvious. Show running system configure information. That means the show command is to show you information. All right, the running config, obviously, right, because that's what's in RAM, and that's what the device is being controlled off of. That's not the start command. Wow, man. Okay, Kyle, just slow down for a second. Wow. Okay, lost for words this morning. Must be the damn caffeine because I did have some tea this morning, some black tea. So now we're gonna say show. If I want to know what commands comes after show, then I am not going to do a question mark here because that's the command itself. I'm going to do a space and question mark, and that's all the commands that come after show. Okay? And let's find our command we were using, Mac. Mac configuration. Tab completion. Okay, right? Now, if I just did, because I don't see any MAs, so all I have to do is hit M, but no, because I have memory. I said MA, didn't I? All right, tab completion, there we go. All right, so question mark, address. Now, I have two A's there, so that's not going to work, but AD, bam, my command is completed. How do I know that? Because at the end of this question mark, there is a CR, a character return. See that? Okay. All right. Now, do not worry about all these MAC addresses, okay? Because these are statically configured in the system, okay? However, over here, if we go back to the top, this is your VLAN list. Okay, and as you see, I have VLAN 11, VLAN 1, and VLAN 50. Okay, it tells you what port they're on. Yes, I know they're all on the same port. Well, you'll learn that later on. Okay, and this nice little digit here. Now, remember we talked about hexadecimal, right? All right, so each one of those digits, okay, are hexadecimal. Each digit is 4 bits in length. Okay, 4 bits equals what? 1, 2, 4, 8. Add those up. 8 plus 4 is 12. 12 plus 2 is 14. Okay, and 1 plus 14 is 15. All right, that means if we have 15 possibilities, how do we put that in one digit? Well, 0 through 9 is pretty easy, but that means we have 10, 11, 10, 11, 12, 13, 14, 15. Huh. Is that right? Oh, I did what we always do, forget the 0. So that is 0 through 9 will actually equal what? 10. So that means I have 11, 12, 13, 14, 15 left. Okay? So if I have that many, how do I recognize or represent 11, 12, 13, 14, 15? By using the characters A, B, C, D, E. Okay? All right? Now, but it's 15 in length. Okay? 0 is 0. 0 is not 1. Okay? Aha. Yeah, I kind of tricked you there on purpose. 0 is 0. It's not 1. 9 is 9. 10 is A. 11 is 12. Yeah, you saw I did. That was a mistake. 10 is A. 11 is B. 12 is C. 13 is D. 14 is E. And 15 is F. See our F here? In this number? Okay, if I just want to select one, it's kind of hard. All right. So there's our F. That is a value of 15. Okay. Why am I telling you all this? Well, let's go back over to here. I'm going to say IP config. Okay. We're going to max this out. And you see I have like this IP version 6 number, this IP version 4 number, but that's it. Okay, but if I do ipconfig /all, the / on the DOS command line, okay, for Windows is a switch. Okay, so our switch, which is used as a /, okay, all is the command we want to use. However, in DOS, we can use a question mark with the switch, and it will give us all the possibilities and all our switches we can use with a description. Same thing as Cisco. Pretty cool, huh? Windows has this help as well. Okay. However, let's go ahead and clear this screen here, CLS, and I'm going to say ipconfig all. Now, the problem is, it's giving us stuff that we don't really care about because we're not using those adapters, but we're looking for the one that has a 192 address on it. There it is. Okay. Which is my Wi-Fi. Oh, yeah, it is the wireless. I'm not plugged in. Okay. So now, okay, notice that it says preferred here. Okay. All right. But when we do the all command, all right, it gives us an interesting set of numbers here. Physical address. Now remember, each one of these, there's our F again, right? Each one of these digits is 15 bits in length. Okay? Okay, let me say that. Let me rephrase that. It's not 15 bits. It's 4 bits. All right? Okay, yeah, I know I'm screwing up big time here. It's 4 bits in length. 15 possible values in each. But if it's 4 bits in length, we have 1, 2, in each one of our um, values here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a MAC address or physical address or a burnt in address has 4 bits in each spot, 12 spots altogether. How many bits is a physical or MAC address or burnt in address? 48 bits in length. Okay, this is something that is physically burnt in or physically configured, okay, on every network card. Okay? And ideally, the concept is for it to be unique. All right? Now, I can't tell you that you'll never find 2 of them with the same MAC address because it's happened to me. Now, the chances of it, maybe they've done, because of something like that, that has happened in the past, maybe they have new criteria in place where it'll never happen again. Or maybe there's so many damn network cards in the world that, nowadays that the chances of that is astronomical to none. Okay? All right? I have never seen it in my 15 years in the network field. Okay? I was in computers, back in the 90s. Okay, when it actually happened to me. Okay? Now, and I was not a network guy in the first place. Okay, so it wasn't even my field. So, but it has happened. Okay, but it's not supposed to happen. All right, that's why it's so long, and that's why it's supposed to be unique. Okay, now these switches. Okay, when you plug a device into this device, into the switch, and I don't care if it's wireless, if it's a wireless access point, it's going to record the MAC address. Okay, these switches. Okay, every time data is sent from a device onto a switch. Okay, the first thing it sees and pays attention to is the MAC address coming from that data. Okay? Now remember what I told you. You need 4 things for communication to happen. Source IP address, destination IP address, source MAC, destination MAC. Don't have one of those things, your packet will not even be sent. The TCP IP will not even send the data. All right? It's broken. You need those 4 things. Remember that. All right? Always remember that. All right? Words and names is not necessary. Okay? We can use words and names because of DNS. Okay? But as far as communication, if we do not, and we need DNS to convert that word back to an IP address so we can send the data. Because without it, it goes nowhere. Your DNS broken, bam. Okay? But if you know the IP address of the actual destination, you don't need DNS. All right? If you need the IP address and want to know the IP address of the DNS, then ping it. Okay? So, and have the DNS resolved. Okay, so ping www.google.com. Okay, and there. You see that? DNS resolved it for you. That's the IP address of google.com. Well, for my location anyway. All right, so there you go. Okay, now, so the first thing the switch does is it looks at the source MAC address. Okay, then it goes and says, you know what? This is coming in on port 1. Okay, do I have an entry for port 1? No, I don't. So now what I'm going to do is, okay, I am going to record that source MAC address onto port 1, All right, and guess what? It is now in my database. Okay, so that means on port FO24, okay, this MAC address was dynamically learned. This is the MAC address that is set on FA24, and it's in VLAN 1. Now, the cool thing about this is now, intelligently, when I go to send data like on port 5, and it is destined for the MAC address of this one here that I have highlighted, okay, the switch automatically only sends that data to one port and one port only, and that is where the MAC address resides on in its table. Now, let's say we go back over to port 1 and we unplug that PC and plug in another one. Obviously, it's going to have a different MAC address. So, first thing, every time data comes in, this is what the switch does. Every time, it looks at that source MAC address and it compares it. Now, this MAC address is something else. That's not what I have recorded on port 1. So now I'm going to take port 1 and eliminate what's in my table and replace it with the new MAC address. Okay? There's no way in hell for you to actually get past this switch looking at every packet or frame that comes in there. Okay? This is cool. All right? Because now we're not wasting bandwidth by sending data to every port out there. We're only sending data where it needs to go. And now you know why you must have the destination MAC address. Okay? And where do we get this? How do we build this? Okay? All right? Here's another command for you. Show IP ARP. Okay? This is how we do it. Okay? All right? We build our information, our source IP address, okay, and destination IP address from the ARP table. Okay? All right? So far we know we have a MAC address table and an ARP table. Does our PC have an ARP table? You betcha. Oh, no. Hold on. There we go. Okay? So, now a dash, okay, is the same. So let's, it's the same as the switch. So let's do a question mark. See, instead of doing forward slashes, they're dashes. Okay, and then and look, dash A is what I use. Displays the current ARP entries by integrating the current protocol data if internet address, which is the IP version 4, is specified, the IP and physical addresses for only the specified computer are displayed. Yeah, so this is Microsoft's version. Sorry about that, guys. But you get the idea. Okay? That's why I use dash A. All right? Okay? I want to know if it's dynamic or static. Okay? All right? And notice this one, okay, is all Fs. Okay? All Fs in the MAC address is telling the switch. Okay? Remember, these switches are intelligent devices. Okay? All right? We don't use hubs anymore. I mean, why would you? Okay? First of all, the benefits of a switch outweigh a hub beyond comprehension. Okay? And, they're so cheap now, it doesn't even matter. Cheap from the perspective that, you can go into Best Buy and buy one of those, unmanaged ones. Okay? Got it? Now, so even your PC has an ARP table, meaning that I have TCP IP on my PC. The rules still apply. It's following TCP IP standards. Okay? There's no way for me to send data out of my computer off my network card without having source IP address, destination IP address, source, and destination MAC. So these tables are necessary. Okay? So the first thing it looks at is source MAC address. We covered that. Okay? And forwards out on the same port or the correct port. Okay, so let's talk about the methods of how a switch, okay, makes its decision. All right. So the first one is store and forward. Okay. That means when the data comes in on port 1, the entire frame is stored, okay, before it is forwarded. All right. Any error detection, okay, is going to be done after it is completely filled up in the queue and stored. Okay. All right. No error recovery whatsoever, though. Okay. It might find an error, but it'll mark it as an error, but it'll still send the data, and and it is just the way it is. That correct the data. Okay. All right. Now, cut through. Okay. As it's coming in. All right. It's going to start sending the frame out before the whole thing comes in. Now, there's no error detection whatsoever. And this is called fast switching. Okay? All right? We don't have to sit there and wait for it to be stored and come all in before we start sending it out. This is great. All right? Nice and fast. Okay? Now, fragment free. Okay? This is pretty cool. If the frame is corrupted, it's going to be found in the first 64 bytes anyway. So we're only going to look at the first 64 bytes. Okay? And if none is found, we're going to forward it. However, if it is found, sorry. Okay? So those are the three methods. Now, I'm not going in depth to this because I'm going to tell you right now, all right? Unless there's something really, really wrong with your switch, meaning that 9 times out of 10 you're going to be talking to Cisco anyway, okay? Never do I have to worry about these methods whatsoever, unless for some strange reason. And here's the thing, okay? Here's the thing. When I get a device, I'm going to check out the release notes anyway, okay, for that particular device. All right, if I'm not familiar with it, okay, and if this needs to be recognized or checked or so on and so on, 9 times out of 10 is going to be in release notes anyway. So data stuff like this, yes, you kind of need to know. All right, so when it comes up later on in your career, you'll be like, oh yeah, I remember that. Okay, all right, and you have some understanding of it. And for the exam, yeah, they could definitely ask you questions on that crap. All right, so from that aspect. But as far as it being relevant to your day-to-day work stuff, you're going to come across that during research. Okay? Like release notes and bug reports and things of that nature. Does that make sense? Okay, I hope it does. All right? And we're going to stop this video right here before we go on to the next one. Actually, we can talk about this. All right. So now, a switch, the intelligent part of the switch, is what to do with the data. Okay, when it comes in. Okay. My first choice is to forward it. Now, I'm going to forward it if, okay, the destination MAC address is in my table. Okay. All right. If I look at the destination MAC of the actual frame coming in, and it's in my table, that's a easy decision. I'm gonna go ahead and forward it through my table. You go and sending it out the port that the destination MAC address sits on. Okay. All right. Or I'm gonna filter it. All right, meaning that, okay, if I'm going to, if a, remember that all F's in the MAC address, okay, that's a broadcast message. So the switch knows I'm going to forward that all ports. However, that message of flooding came in on port 1. Why would I flood that information back out port 1? No, I'm not going to do that. So you're going to hear me say it will send it out all ports except the port it came in on. Which will make sense. Why would I send the data back out? Okay, I'm the one who sent I'm the one who sent the broadcast message. I don't need that data back. All right, I need to go to everybody else. Okay, all right, and that's what flooding is sending out all ports. Now, there's 2 ways to flood. All right, and it could be more. I don't care. I'm going to tell you about these 2. 1, I send out a destination MAC address of all F's. Okay? That is automatic flood. Another flood is a unknown MAC address. What's going to happen is I send a MAC address with a destination of AA. Okay, I'm only going to just think of all of them being AAs. Okay. However, AA is not in my MAC address table. It's an unknown MAC address from that switch perspective. So what do? The only thing that will be logical is to flood it out all the ports except the one it came in on. Okay? Does that make sense? All right, so these devices have a little brain to them. Okay? All right? So we know what broadcast addresses do. All right? And remember our subnetting. NFL ball. Network address, first valid, last valid, and broadcast. Meaning that if I ping a broadcast address, okay, the destination of that broadcast address, which would be, that's the MAC address. Let's go ahead and clear this. I gotta do it all. I'm looking. That's weird. I could have sworn it was in here. Where did I see that? La 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 la. Okay. I'm gonna show you another command. Route print. Okay. Now, route print shows you the routing table of Windows. And you know it really trips me out because I saw the broadcast. You know what? It might have been on the ARP table. Hold on for a second. Yes, it was. Okay. Yes, it was. Okay. This is our broadcast address. Okay. It's statically entered because this is TCP/IP doing its job. All right. It knows the subnet mask. Okay, because it was given that information via. Okay, via what? Via DHCP. Okay, it knows its address. Okay, which I think is probably like 151. I think. All right. So, okay, that's the address. So it has the address and the subnet mask, which we'll find by doing this. Okay. 255 to 255 to 255.0 and 160 is the address. Sorry, not 151. Okay, it has a default gateway, but with this 2 information, the IP address and the subnet mask, it knows that the broadcast is 192.168.1.255, meaning that if I ping this address, my destination MAC is going to be set to all Fs. That pinging that address is going to send this message as a broadcast message throughout all ports except the one it came in on. and anybody on this network will respond. Wouldn't this be an interesting tool to try to figure out two things? One, who is able to respond on this network? One, and two, to propagate my arc table fully. Now, sometimes this works, sometimes it doesn't. Okay? And I've used the broadcast address to find out other devices out on the network. And then I will look up its MAC address to find out what it is. Okay? And you can always go online and do a search for MAC address lookup. Okay? And you put the MAC address in there. And the cool thing about it is it'll at least tell you what type of device it is. You know, it'll definitely say this is a Cisco, you know, this is done by Cisco, because the first 6 digits, okay, are assigned to the manufacturer by an organization. Okay? The last 6 digits, okay, that is assigned by the manufacturer themselves. Okay? So each one of these digits, the first 6, will tell you what company that network card is from. Okay, now if it's a generic company, you won't be able to know. But if it's something like Cisco or Juniper or Brocade, okay, it's gonna come up and tell you, you know, this is a Brocade device. Okay, pretty cool, huh? All right, so last thing we're gonna talk about is a broadcast storm. Okay, all right. We have mechanisms to stop broadcast storms, but broadcast storms are real. Okay? And I want you to think about it. Okay? We got 2 switches, okay, and they're connected together with 2 cables. So what have we done? We've given it 2 paths for that data to go out of, but 2 paths for it to come into. Meaning that I can go out port 1, and that same piece of data could come back in from the other switch through port 2. Okay? It's a loop. I just created a circle, right? Okay? Port 1 to port 1, port 2 to port 2. Between the switches, I just created a circle or a loop. Okay? And imagine that data, okay, going out and keep repeating and keep repeating and keep repeating, okay? And now you got 1 frame. Then it comes back. Okay, now just imagine there being a broadcast address. Okay? You got the broadcast going out, okay, it's coming back in, it's going out, it's coming back in, and they keep responding back and forth, and now you got the same frame that should have only gone to the destination and ended, okay? Alright? After the communication is done, but it keeps getting added and added and added and added. And now we have this frame that has been repeated, and repeated, okay? And it is wrapping around, and it never dies. And it just gets more and more and more of these frames, and now you have had so many of these copies of these frames, okay? Going back and forth, that it has saturated the bandwidth between those cables, okay? And now your CPU is maxed out because it is processing all these frames, okay, that started off with 1 and now is thousands of them, okay? And now your switch is too occupied to send any data, and now your communication from device A to device B is broken. Broadcast storms are no joke. They can propagate to other switches, okay, and bring your network to a halt. Okay? Alright? So that is what a broadcast storm is. And now we're going to end this video. And do you see how messed up my words are today? And I'm going to leave you with my famous words. Be strong, be determined, be Cisco.